We will now leave set theory to move on to logic statements. And we have a quote here by Lewis Carroll, who is the famous author of Alice in Wonderland. And something that is not very well known about him is that he was actually a mathematician. And the quote is, "If you don't know where you're going, any road will take you there." And I like this quote because it's very deeply set in logic. That's what makes it an interesting quote. So we start with a definition. A statement is a sentence that is either true or false, but not both simultaneously. A statement can either be true or false, but not both at the same time. So, let's look at some sentences that may or may not be statements. The first one, this book is a good one. Is that a statement or not? It is not a statement because it is an opinion. The second one, it is raining in Camden, New Jersey. This one is absolutely a statement because it is verifiable. It is either raining or it is not in Camden, New Jersey. It cannot be both raining and not raining. Unless it's raining in certain parts, but that's getting nitpicky. And then the third one, there is no female president in 2013. You might immediately think that this is a statement, but it is a little too vague. President of what? So this one is not a statement. So you have to be careful of what you think of what is a statement and what is not a statement. Moving on, we have a new definition. In previous classes, we learned that the intersection, if you land in the intersection of two sets, you're there because you came from both set A and set B. In logic, we use a very similar symbol, just a pointier one, and we say P and Q means P is true and Q is true. P and Q means P is true and Q is true. Similarly, we have that the union, you ended up in the union if you were there because you came from A or from B, or both. And in logic, P is true or Q is true. This is the symbol for it, and it means P is true or Q is true or both are true. So, if we have a statement, something like this, I have a penny and I have a quarter, then we would say that the first statement here is I have a penny. The second statement here is I have a quarter. And if we're writing this in symbolic logic, we just write P is true and Q. I have a penny and I have a quarter. Where I have a penny is P, and is the and symbol, and Q is I have a quarter. Similarly, I have a penny or I have a quarter. We'll call this P once again. I have a penny is P. We'll call this Q. And then we have our or symbol. So I have a penny or I have a quarter. It's an ugly or. Or I have a quarter. Now we also have one more thing to address. Just like in set theory, we have the complement, or the things that are not in set A. In symbolic logic, if P is I have a penny, we need to know what I do not have a penny is. And in symbolic logic, this got a little messed up. It's a little tilde P. And that means I do not have a penny. So the negation of a true statement is a false statement. Now, letters should only be applied to statements which are not negated. For example, here, we have to choose P and Q. We have, you did not study for the test, and you did not pass the test as our first question. So let's say P is you did study for the test. You studied for the test. And we can say Q is, remember we're not applying it to the negation, so Q is going to be you passed the test. And then once we have our letters, and the reason we do this, the reason we write our letters without negations, is to avoid any confusion, to avoid double negatives, to avoid saying not. So you did not study for the test is the first part of this sentence. How can we write that symbolically? Well, we'll write you did not study for the test, not P. Then we have an and. We know our and symbol. Then we have you did not pass the test, so not Q. You did not pass the test. So take a minute and try the other two on this page using our P and Q. The first one says you did study for the test, so you studied for the test, so we have just a P. And you did not pass the test, so this time we still have the not Q. And now the third one says you studied for the test, or you study for the test. I put it in past tense, I probably shouldn't have. You study for the test, P, or we have our or symbol, you fail the test. Now this time it doesn't say you did not pass the test, but if you didn't pass the test, then you failed the test. So we can still use our not Q. Sometimes you have to use just the English language to change things into the logic that we can use to then make it symbolic logic. So moving forward, if we have P, London is the capital of England, and Q, William Shakespeare wrote the television show Modern Family, what would be the true statement here using symbolic logic? Well, London is the capital of England, so we would have P. And then we would also have and William Shakespeare wrote for the show Modern Family is not true, so we have P and not Q is the most true statement here. But we have a few other true statements that we could have here. For example, I could have not P or not Q. Well, this is true because what does it say? It says London is not the capital of England, which is false, but then we have an or symbol, and then it says William Shakespeare did not write for the show Modern Family. If I said unicorns are real or it is raining, and we all know it's raining, then my statement is true, because even though unicorns aren't real, it is still definitely raining. So there are a few different ways we could have true statements here. The most true one would be P and not Q. What about this one? Paris is not the capital of Spain, and July is a month. So if we were doing this one, we're writing it using symbolic logic. So instead of using the A and B here, I'm going to get rid of the negation in A. I see the word not, and I don't like that. So we'll say P is Paris is the capital of Spain. Q is July is a month. And now to write this using symbolic logic, I would just say, well, what's true here? Paris is not the capital of Spain. How can I write that? Well, I write not P. Paris is not the capital of Spain. And July is a month. So just Q. So whenever we transfer things into our P's and Q's, we don't want negations. We don't want the word not. Because otherwise we might get to a point where we have to say the word not a few times and then we lose the meaning of the sentence. Now continuing, we have this statement again. We have I have a penny and I have a quarter. And remember we said that this was P, this was Q, and this was and. So we had P and Q. And what we do is we make something called a truth table. A truth table. And what a truth table is it tells you all the possible ways this statement could be true or false. So we have two statements. So let's just set them up as P and Q. And now there are a few different ways this could go. Either P could be true and Q could be true. Or maybe P is true. Maybe it's true that I have a penny, but it's false that I have a quarter. Maybe I only have a penny. And then, opposite of that, I could not have a penny but have a quarter. And then they could both be false. So that's P and Q in all of the possible ways they could be true or false. And what a truth table does is we take a statement like P and Q, and we say, when is P and Q true? In which of these situations? Well, if I have a penny and I have a quarter, then P and Q is true. I have a penny and I have a quarter. But if even one of these is false, if I don't have a penny or I don't have a quarter, then it's going to be false. So for example, in this case right here, and I'll change my color. I'll try to change my color. I'll change my color. We have P is true, Q is false. So what this would tell me is I have a penny, but it's false that I have a quarter. I have a penny, but I don't have a quarter. So the statement P and Q, I have a penny and I have a quarter, is wrong because I don't have a quarter. So that would be false right there. And then similarly, if I didn't have a penny, it would be false. And then it would be really false. It'd be really wrong of a sentence if I asserted that I had a penny and a quarter and I had neither. This would be very wrong. So this would also be false. So we end up with a truth table for P and Q where it's only true if both statements are true. It's only true if both statements are true. And we call this a conjunction. A conjunction is only true when both simple statements are true. Conjunction. And we see that maybe a little more clearly if you didn't understand my explanation in this example right here. So we have a statement. Let's go through the whole table. We have a statement. 3 plus 2 equals 5, and London is in England. We have two statements combined with an and. We have a conjunction. Well, it's true that 3 plus 2 equals 5, and it's true that London is in England. Hopefully you knew both of those things. So our truth value here is true. Both statements are true. If you look in the next piece, it says 3 plus 2 is 5, and London is in France. Well, the minute a piece of this is false, the minute a piece of this is wrong, the whole statement here is false. It is not true that 3 plus 2 equals 5 and London is in France. So since the second statement is false, the whole piece is false. Same with the third piece. We have 3 plus 2 equals 6 this time, but London is in England. The reason our statement's false this time is because the first statement is false. And then a really incorrect sentence is 3 plus 2 equals 6, and London is in France. Both halves are wrong, so it's definitely false. And this is different from the or statement. I have a penny, which is P, or I have a quarter. I have a penny or I have a quarter. Setting up the same truth table here. And the trick for setting up this truth table, we'll do P or Q. The trick for setting up this truth table is that we have true, true, false, false, and then we have oscillating. We have true, false, true, false. And then you have all four possibilities for P and Q. And now the or statement. If I have a penny or I have a quarter, if that's the statement and both our pieces are true, then I'm not lying to you. I have either a penny or a quarter. In fact, I have both. So we have a true statement here. If the statement is I have a penny or I have a quarter, and I do have a penny but I don't have a quarter, well, I'm still telling the truth because I have that penny. Similarly, in the third case, I have the quarter, so it's also true. So the only place that this one is false, the only time an or statement is false, is if I don't have a penny or a quarter, if I don't have either of them. So it's going to be only false if both simple statements are false. And we have a name for this one. This is a disjunction. A disjunction is only false when both simple statements are false. And we have the same table set up to explain with our 3 plus 2 equals 5 and London is in England. In our first piece, we have 3 plus 2 equals 5 or London is in England. Well, it's definitely true because both components are true. And then in our second piece, we have 3 plus 2 equals 5 or London is in France. Even though London is not in France, even though this right here is false, We have an or statement, so we only need one piece to be true, and 3 plus 2 equals 5, so the first component is true. In the third case, London is in England, so as long as we have one piece true, we don't even have to worry about the first piece. So the second component's true there. But once both pieces are false, we can't avoid it. The statement is definitely false. Both simple statements are false, so our whole statement is false. And that is the logic behind truth tables. We'll do a little more with them in the